This is a review for the final. Everybody make sure that you are either turning in on Friday or the final day. Okay. And it is cost it will give you 30 point, and it is not extra credit. This is mandatory 30 point. If you don't turn in, you will get a 0. Okay. My senior, if you were doing this paper, well, actually you are doing this paper and you turn it in to the substitute teacher on your last day of the class, which means Friday. If you're not coming on Friday, you have to turn it in before that, or you have to drop it in on the final day, or you get a 0 point instead of 30. Okay, so let's get started. Take a look at these. So first thing first, these are from periodic table, and you're doing ionic compound naming. Ionic compound naming go according to the charges, so you got to know how to use your charges. Make sure you're using your charges. So first thing first, we have beryllium. Make sure you pay attention to periodic table. Beryllium is here, called Be, beryllium, right? So we're gonna write Be. Beryllium is gonna be +2. How do we know? Because it's in a group 2. So group 2 is a +2, right? We have +1, +2, and then we got +1, +2, +3. Okay, and then these are -1, right? That's group -2, -3. Okay, so you have to know that. Nitrate, that's on the back of the paper. You're gonna look in there and then you'll see that that's NO3 -1. Okay, when you're doing this, you want to make sure that the charges are balanced. So 2, 1, that means I'm gonna times it by 2 to make it -2. Okay, and this one has 2 elements, so that when you write it, you need to write the parentheses. So you're gonna say Be parenthesis NO3 parenthesis 2. That's how you're gonna write it. Okay, the next one I want to do really quick. I'm not gonna explain it anymore. K is +1, sulfate is SO4 -2. So therefore, again, this is times 2, K2SO4. Okay, the next one, same thing, ammonium. Make sure you understand what's ammonium. It's NH4 +1. Ammonia is NH3. Ammonium is NH4 +1. Phosphate, PO4 -3. Again, 2 element, NH4 parenthesis 3 PO4. That's how you're gonna write it. Silver is Ag. If you look in periodic table, you'll remember that that's my +1 that we talk about. Sulfide, notice that is IDE. That means it just S -2. Okay, so when you put it, you're gonna say Ag2S. Manganese. Be careful with this. Manganese versus magnesium, definitely different. Manganese is Mn. And this 2 doesn't mean down here. This 2 is actually +2. Okay, cyanide is Cn -1. That's in the back of the table. Even though IDE is this is one of those at the back of the table. So you have to remember that one. Okay, it's a polyatomic. That means I need to make a parenthesis when I say 2. So we're going to say Mn, Cn, all right, parenthesis 2. Why is 2? -1 +2. That means I need to times it by 2 to make it -2. Okay, sodium nitrite, again, nitrite, IDE, that just means N -3. Sodium is Na +1, so it's become Na3N. Calcium phosphide, Ca +2. Phosphide, again, is P -3. That's 2 together, Ca3P2. You got to know that one. Lead, Pb. Okay, again, this 2 doesn't mean down there, it's +2. Carbonate, CO3 -2. This is even. Don't do anything, just write it, PbCO3. Notice when you write the formula, I do not write a charge at all. The charges has to be balanced, and then you just wrote them. Okay, you just write them. You don't do any charges right here. All right, cobalt. Cobalt, be careful with this. It's big C with a little O. If you write big C and big O, that would be cobalt monoxide. Make sure you're careful with that. This is +2 because it's told you here. Chloride, Cl -1. So that this is CoCl2. Notice it's a Cl, not Ci. Iron, Fe, not F. Fe, remember that. +3. O is -2. Therefore, Fe2O3. Okay. Now on the bottom, writing a formula. Writing a formula is easy. If you already know the charge of this beginning one, by looking at the periodic table, you don't need a room anymore. If you do not know them, you have to do it. So for example, zinc, You don't need to write down the Roman numeral because we know zinc is always +2. Be beryllium, we don't need it either because it's always +2. Ammonia, you don't need to write it. Ammonium is always +1. So these three, we don't need to write it. The rest of them, we need to figure out. So for example, Mn, we don't know what it is, but we know OH is -1. That's 2 main times 2, therefore Mn is +2. Okay, so that means manganese 2 and then oxide. Okay, Cu, copper. Oops, sorry. I should be writing Cu. SO4. Now we know SO4 is -2. That means Cu is +2. Okay, so therefore copper 2 sulfate. Okay, Zn, zinc. Okay, again, this one don't need to do the charges, so you can just write it. Zinc nitrate. Okay, those are T, by the way. Iron, we don't know because OH is, we have to figure out. So Fe times 3, PO4 is times 2. PO4 is -3. Times 2, that's -6. That's 3, so that means that should be +2. So we know that this is iron 2 phosphate. Notice that these just happen to be 2. On the test, you might be different charges, might not be always +2. So make sure you know how to do it. Okay, beryllium oxide. Again, beryllium don't need the charges because we always know that is +2. This one is ammonium. Nitrite, careful with that, NO3, so nitrite. Lead, okay, we gotta figure out, we'll come back. Carbonate, okay, NaTe. All right, what is this? Carbonate is -2, and then you have parentheses, that means times 2, that means -4. Since just that one thing, it should be +4. So 4 is IV. Okay. All right. Down here. These are covalent. How do I know covalent? You know covalent because the first letter is a nonmetal. That means that you're gonna use monoditride. So you're not using charges anymore. If the first guy is 1, you don't have to say mono. So you're just gonna say it. So this is carbon. 4 means tetra. Okay, so this is carbon tetrachloride. Notice the second one got name change. It's not gonna stay chlorine, it's gonna change. Okay, 2 mean di, nitrogen, and 5 is penta. Now I wanna drop the A because the next one is start with O, so it's a vowel, so we're gonna drop that. And then it's oxide. Don't write oxygen. Boron is B, okay? Tribromide, that means 3Br. Br3, okay? BBr3. Now next one, CO. Carbon, 1 is monoxide. Okay, again, we don't write the 2O. Silicon is Si. Dioxide 2O, O2. Okay, 2Cl, dichlorine. Okay, 1O, monoxide. Oopsie. All right. Group, these are from the periodic table. You should know. All right. Group 1, start from here. Alkaline metal, alkaline earth metal, noble gases, halogen. Okay, you should know those. All right. So that means it's Li, Na, K, Rb, Cs, Fr. Alkaline earth metal, Be, Mg, Ca, Sr, Ba, and Re. Halogen, F, Cl, Br, I, At. Noble gases, helium, neon, argon, krypton, xenon, and radon. diatomic, starting with H. H2, N2, O2, F2, Cl2, Br2, Ni2. These are all diatomic. Metalloid, those are the one that is around the staircase. This one, this one, this one, this one, this one, and this one. Sometimes they talk about polonium, but we're not gonna include this one, okay? So therefore, B, Si, Ge, As, Sb, Te. Okay. All right. All noble gases has 8 valence electron, except helium. Helium only has 2. You have to remember that. Let's balance these. Okay. 3, 4, 3, 2 times 2, 4. We're done. 2 chemical become 1 chemical together, synthesis. Okay. H2O2. Okay, the problem is on O. If you look at it, this is 3, this is 2. H is balanced. I mean, I'm just going to double that, increase that. Let's see what happens. 4, 4. We're good. 1 break into 2. That's decomposition. Notice your synthesis and decomposition are very similar, but it's the other way around. Synthesis is you have a lot of things as a reactant. Product is only one thing. Decomposition, you have one thing as a reactant and a lot of things as your product. Okay, next one. Another synthesis. Okay, in this case, you have 3 reactant, which is fine. You could have a multiple reactant, right? It just as long as we're making one thing, that's synthesis. Let's try balancing it. Okay, S look balance, H is 2. Let's look at O. There's 4, 1. Okay, that's 5. That's not gonna balance. So let's double it up. Let's increase these, and then let's see what happens. H is 4, S 2. O is 8. 2 plus 2, 4 plus 4, 8. We're good. Okay, that just need to balance on this. 2, 3, 2. SB is 2. I6, we're good. Again, this is synthesis. I'm not going to write this. I'm just going to arrow it down. This one, CR. Okay, FE. Okay, FE is 3. Oh, I already give you 2 here. So, whoopsie, I should have deleted it. But anyway, I'll give you already hint on that. Well, that's 2. That's 2 there. NO3, if you want it together, you can see it together. So you can say 3 NO3 times 2, that's 6 NO3. 2 NO3 times 3. Okay, so or you can individually do N. See that? N is 1 times 2, so 2 times 3, so 6. Okay, same thing. 2, 1, 3, so that's 6. And then you can do the same thing for O. Fe is 3. We're good. This case called single displacement because Cr take the place of Fe. Fe is now alone. This is single. Okay, single displacements. Or sometimes we say replacement. Either way is fine. Another synthesis. Okay, this one is a double displacement. If you're looking at it, you'll see Fe and Ne just switch spot. Okay, they swap them. So that's what's happening. There's 3 of them, 3 here, 3 Cl, 3 Na, 3 here. Okay, this is called double displacement or replacement. Okay, the following are combustion. How do you know? Because they are some sort of hydrocarbon, carbon and hydrogen, and they need oxygen as a reactant, and then they all make carbon dioxide and water. Okay. Balancing. Always, I like to look at H if there is no O. If there is O, you might have to look at it. It's a little difficult. Okay, so I'm gonna look at H. H is 12 divided by 2, 6. We're good. If H is odd number, like this one, all you do is you double this here, and everything else will be good. Okay. So 5, 6, 10, 6, 16, so 8, 9, 20, so 10. Okay, so 10 plus 9 times 2, 18. So 18 plus 10, that's a 28. You see that? 9 times 2 is 18. 10 times 1 is 10, so that's a 28. Divided by 2, 14. That's gonna be go here. Okay. This one we already double up, so we're gonna use that number. 2 times 6, 12. Okay. 12 carbon. H is 14 times 2, but here is 2, so times 14 there. Okay. So O here is 12 times 2, so that's a 24 plus 14. So that would be 8, 3, 38. Okay. That would be 1, 9. Okay. 9 times 2 is 18. So yeah. Right. Okay. I already give you most of them. Actually, this is already balanced because I actually give you everything here. Right. 6K. Right. You can double check if you want. This is double. All right. Next one. Okay, I'm just gonna mark it so that I remember to change it. Don't worry about it. And I think that this one too. I need to go and change it for the later. So, alright. Next one. This is a K replacing MG, and MG is now alone, so this is called single. Okay. This name also went a little bit weird. Don't worry about it. It's actually redox. You don't learn it, so we're not gonna do anything about it. So ignore that one. Because this one kind of look like a double displacement or single displacement, but it's really neither, so don't worry about it. Okay. So this one is, let's see, balancing 2 here, 2 here. Okay. This one, let's just balance it 3 H's. So if I was gonna do 2 here and then 3 here, I think I'm gonna make it odd run risk. Let's just make it full. Okay, let's just make it full. So 4 here, 4 here. Okay, and then 3 times 4, 12. Right, 12. So 2, so that's 6 when I use. 6 times 2 is 12. And then we're gonna have 4O plus 6O, so that's 10O. 5 here, 5 times 2. Decomposition. One thing broke into a million, a lot of places. 2N, my O might be trouble. Let's see. 6O, 2 times 3. Okay, let's see if I have 6. 1, 4, that's 5. That's 2. That's not gonna be 6. So I need to double up. 2, 2, okay, 4, and then double check. Okay, it should be balanced now because 6 times 2, right? 12. Let's see. 2 plus 8, 10 plus 2, 12. Okay, this is decomposition. Next one, this is decomposition again. Okay, what happened? Well, CA break into 2. That's gonna be 2 there. That's gonna be 2 there. That's easy. All right. Let's see how to do it. So that's gonna put it 3 there, and then so I'm gonna put 2 there to balance it. That make it 4. So I'm gonna put 4 here. That's gonna be 3C here. This is single because F, E, and C just change place, although that's an unusual single displacement. The next one is also single displacements, right? MG and H switch place. So that's also single. Okay, so balance 2 there. This one, let's see, 2 there, 2 here, and then 3 here. This is decomposition because you're breaking. Okay. The next one, that's a double because Na and H switch place. Okay, how does it happen? Let me see. We're gonna put 2 there. Na, 2 Na. Cn is 2, H is 2. There we go. This one is decomposition. I mean, not decomposition, sorry, synthesis, because 2 things become 1 thing. Right? Synthesis. All right, next one, double displacement. Ba and K switch place. Double. The next one is single. Right? Mg and H just switch place. Actually, I accidentally wrote it twice. I already wrote one here above there. I'm gonna need to delete that. But anyway, you can just balance it again. This one is a double displacement, H and K switch place. So this is double. Okay, so we have that. Okay, so let's balance the rest. Let's see, I don't think I balanced all of them. S is 2, so I want to put 2 there. Okay, O is 2 times 2, that's 4, plus 2, so that's 6, 3 there. Ba is 1, Cl is 2, so I'm going to put 2 there. For that, that make K3 2, and then that make IO2 2, which is perfect. Okay, let's balance the last one. K is 3. Okay. Now, same like PO4, I just need to check H, I guess. That is 3, 3, that's 6. So that means 3 times 2, 6. Let's check for O. 3, 4, that's 7. 4, 3, that's 7. Good. Okay, the next two, I actually make a mistake. The first one is single. The next one should say double because you're doing double displacement, not a single displacement. Okay, the first one single. Single is a little tricky. You have to pay attention to diatomic, or you have to pay attention to which one they're gonna replace. Okay, Li is a metals. I mean, it's gonna become plus, so it's gonna replace something that is plus. So H and Li gonna switch spot. Okay, so H gonna become alone, and Li gonna to be with Cl. At this point, you want to double check charges. So Li is +1, Cl is -1. They are good. Otherwise, you have to put the subscript down there. After they're good, you have to check this guy, alone guy, to see if it's diatomic. If it's diatomic, which is this, now put 2 there. Once that is done, you're gonna do balance left and right. So now we're balancing. 2 there, 2 there, 2 there. Okay. Next guy, same thing, Br. You have to think which one Br like to replace. Br is minus, it's gonna replace I. So that means K and I is gonna go together. Okay. So you're going to have Ki plus Br is going to be alone. I mean, sorry, K and Br. What I'm saying. And then I is going to be alone, right? So this is going to be your I. Okay, ignore that. Okay, just say that this is a big I. Okay, now what's happening here? KBr. You got to double check your charges. Charges are good, +1, -1. This one, I, is the diatomic. So you got to remember that. If it's diatomics, what's going to happen is they're going to become 2, right? So you're going to put the 2 there. Okay. Now you're going to balance 2 there, 2 there. More balance. Okay. Double is easier than singles because you're just literally switching the first two. Al and Ag switch. So that means Al is going to go with NO3. Ag is going to go with Cl. Notice that I don't keep the subscript Cl yet. I want to double check charges. Al is +3, NO3 is -1, so therefore we need to do this. This is +1, -1, they are good. Now you're going to balance left and right. Okay, so I'm going to put 3 there. That make this to be 3, Cl is 3, we're good. Same thing, Na go with Cl, and then Ba go with OH. Double check your charges. NaCl is good, 1, 1. This one is not good because Ba is +2, OH is only 1. Okay, -1 plus 2, so we're going to do time 2. I mean, we're going to balance it. Now they're balanced. Okay. All right. If you still need this balancing help, I would go and look at fat simulation on the balancing. That's going to help you with balancing. If you still have problem with naming stuff, I would go and look at like YouTube video or something, talk about like how to name these ionic compound, covalent compound. This you just have to remember, okay? Groups and stuff, you just have to remember this one. If I were you, I would memorize it. There's a lot of question on this one. All right, next one. Okay, on the test, I give you formula sometimes I don't give you formula, so you still should know. I'm gonna actually work on formula first, and I want to do molar mass. Okay, formula: ammonia, NH3, silver acetate, AgCH3COO. Acetates on the back of the periodic table, so you can find it. Zinc is Cn, nitrate is NO3, charge balance. That's why I put in 2 there. Sodium and A, I'm going to put 2 there because it's plus 1. Carbonate is minus 2. Okay, that's why. Ammonium, NH4. I'm going to do 2 there because it's plus 1. Sulfate is minus 2. All right, now we're going to balance them. Write the molar mass. So to find molar mass, really easy. You're going to look at your periodic table for the mass of N. Okay, how do you find it? Right there, that's your molar mass. Okay, so you're gonna say N is 14.01 plus H 1.01 times 3. That's what you're gonna do, equal, and then you're gonna get your answer. Next one, same thing. Ag is 107.87 plus H is 12.01. Okay, if you want, I can say plus and then plus later, or I can say 12.01 times 2. Either one is fine. Say I already start writing plus, I'm just going to continue. H is 1.01 times 3 plus another C. Like I said, if I don't write times 2 here, I just write it again. Okay, O is 16, but this time I see 2O times 2. Okay, either one's fine. All right, guys, I'm assuming that you guys know how to do this calculation in your calculator, so I'm not gonna give you answer to the calculation. If you guys are wondering how to do this, or if your answer match, I would actually Google like molar mass of these 9, and then they will give you molar mass. Okay, so if you're not sure, you want to double check, you can do that way. The number could be off by some decimal depending on which period table you use, because they do have a little bit different in molar mass, a little bit on a decimal level. Otherwise, they are mostly the same. Okay, I'm just gonna continue. Zinc is 65.39 plus N is 14.01. This time, remember, this N is only 1, but it's actually times 2 because the parenthesis. Okay, O is 16 times 3 times 2, which means 6, basically. All right, Na 22.99 times 2 plus C 12.01 plus 16 times 3. Okay, next one. 14, sorry, that would be 14.01 times 2 plus 1.01 times 8 plus 32.07 plus 16 times 4. Again, you're going to solve for all this. The answer you need is actually you're going to get in gram over mole, which is what you can use to find the next part, unit conversion, which we're going to do. I'm gonna set it up. I will calculate only one question for you guys, and then the rest you can actually plug in the calculator. Okay. This is a train track method that you're doing, or the dimensional analysis, basically. 52.7 gram. I do not want a gram. Gram go on the bottom, mole go on the top. Look at this molar mass unit, gram per mole. That means that 73 attached to the gram. Okay. 1 mole. All right, we're going to do a calculator. Pretty much your unit should be able to cancel, and the leftover unit is what you want, which is mole. All right, if you're on the bottom, you're dividing. You're going to say top divided by bottom. Okay, by this point, I am assuming that you all know how to divide this. So if you do that, you will get 0.713. I'm just going to round it. Okay. On the test, you're gonna find nearest answer that I give you. Some I might ask for specifics. Mostly, you just choose the closest answer. The next one, like I said, I'm just gonna set it up. I'm not gonna do it. Okay, gram. I don't want gram. Gram on the bottom, mole on the top. That would be 58.44, given right here. Okay, moles to gram. Same idea. You're still gonna do that. You're gonna pick 3.25 mole. This time I don't want mole. Mole go on the bottom, gram go on the top. Again, numbers attached to the gram. Okay, so that means you are actually multiplying this time and your answer is going to be more. Okay, another setup. Mole, gram. Okay, mole is 1 mole, gram is 44.01. Alrighty. Okay, limiting reagent. This is the sandwich problem that I talk about. Watch it carefully. This reaction, every time you're gonna do this reaction, you need 2 more of this. Okay, you have 8 more. Every time you need 2, you have 8 more. How many times that you can do that reaction? Okay, basically you're doing 8 divided by 2. That means 4 times I can do it. This one, let's see. You have 18 mole of C. Each time you're doing, you can do three more. You need 3 more. So that means 18 divided by 3, 6 times. That means Fe2O3 limiting reagents, because it can only run 4 times, because after the 4 times, all your Fe2O3s run out. Okay, so answer is Fe2O3. You're gonna do the same thing to the next one. Okay, double check here, 2. Okay, so that means I can only go 5 times. Here, I can do 4 times. That means this is a limiting reagent. O2 is my answer, the limiting reagent. That means it's gone first. Okay. Next one, 16. Every time I can do 2, right? That means I can do 8 times of this reaction. This one, every time I need 3, so it doesn't break even. Okay. About 6 to 7, basically. But usually close to 7. But either way, still last. This one is gonna run out first. Okay, that's S, by the way. Okay. All right. The next one, I have 7 more. I can go to 7 times. 3. Okay, that's less than 5. So obviously, that's run out first. Okay. Next one, 9. So about 8.5, I would say. This one, 3. So I can only go 3 times. FeNO3 2 is my limiting reagent. Okay, so notice again, it doesn't have to do with how much you have only, it's also had to do with your coefficient of the balanced chemical reaction. All right, cation, anion. What is the charge of cation? Remember that, T plus, anion minus. How do we form cation? Okay, that means they are plus, that means they lose electron. Anion, gain electron. Okay, who is smaller? Cation are smaller. Why? Because they has less electron. Okay, anion are larger. Why? Because anion has more electron. Removal of proton, that is gonna create a new element. Hopefully you guys remember that. This is the nuclear reaction where you go from one element to another. Neutron, electron remove, that is gonna create a cation because they become positive ion. Okay. Remove neutron, that's just isotope. Okay. Ionization energy require or need to remove an electron. Okay. Radius, how is it increasing? Remember the drawing. They are increasing, going down the group. Okay. Left to right, remember that? So that means they are increasing right to left. Okay, basically increasing this way or this way. Okay, ionization energy increasing. Ionization energy is backward of radius trend, so that means this should be up, and then this should be left to right. Okay, this one I need to look at the periodic table for this. Highest ionization energy. Make sure you pay attention to that. Okay. First thing first, I always take a look at periodic table to see where they're at. I have B here. Al is underneath there. Ga is underneath there. Okay. and then N is next to B somewhere here, and then F is here. Great. Highest ionization energy, that means small less radius. Okay, that's usually what does it mean. We all know that smallest is gonna be top this corner because right is happen like that, and then going down is getting bigger. So we know that the answer in this case is F. Okay, largest atomic radius. Let's try to figure out where they are at again. You have K on the period table, CO is somewhere here, FE is in between them. You also have MN in between them. And then BR is down. No, BR is all the way down here. Oh, sorry, BR. All the way down on this side. Okay, so here's what happened. Going this way, radius is smallest. That means this is the biggest. Okay, next one. Smallest radius. Smallest radius are the plus, not minus. The bigger the plus, the smaller the radius is. Right there, Mg2 plus. Highest first ionization energy. Highest ionization energy, smallest radius. Okay, usually that helps. Let's try to figure out where is this. K is here, BR is somewhere down there. Okay, FR is somewhere down here, and then you have FE is somewhere in the middle of K and BR, and then KR is after there. Okay, smallest radius up that corner. Here we have a tiniest one. All right. Increasing ionization energy, lowest to highest. Okay, ionization energy lowest is largest radius, okay, to the smallest radius. Okay, that's what we're doing. So let's try to figure out Li, N, F, okay, K is underneath the Li after the Na, obviously, and then Rb is somewhere underneath the K. All right, so we're gonna have that. Smallest is obviously F, okay, largest would be Ra. So like that, okay. So we're gonna say Ra is the largest radius, okay. So and then after that you're gonna have K, Li, N, and an F, okay. Oh, sorry, can't see that. Which of the following correctly lists increasing ionic radius, smallest to radius? Okay, smallest to largest. Let's try to figure out where they are. BA, BE, CA, and F. Smallest radius, largest radius. Okay, smallest to largest. F, N, BE, CA, BA. My answer. Next one. Lowest ionization energy. Again, lowest ionization energy meaning largest the radius. Okay, so let's try to figure out where it is. CA, Mg is on the top, K is next to here, FR is all the way down here, and then CL is the same slope as this. All right, good. All right, so let's try to find the lowest ionization energy, that means largest, FR. Largest radius, lowest ionization energy. All right, as for drawing, these so that you just kind of know what it is. Pentane means 5 carbon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Methyl, that means one of the branch like that. Okay. Except that is a really bad question because I should probably tell you what carbon is attached to. It can be attached to the first one. Okay, so I'm just gonna assume that this is a 2-methyl and then it's kind of look like that. Okay, or if you draw a branch, 1, 2, 3, 4, 5, like that, and then like this. Okay, pentene, if they don't tell you, that means your double bonds on the first carbon, like that, 3, 4, 5. Okay, obviously I'm not drawing all the H's, so there's no H's drawn here, but you should draw the H's, and on the test, your multiple choice, you will have H's in the question, okay? and then 2-methyl right there. Or again, can draw it like that, like that. Okay. Now on the test, would this be also draw another way around? Yes, you can. I can draw it like that. Okay. And I can say double bond here, and then like this. Or I can say double bond here and then here. Okay, either way is fine. All right, 2-methyl pentane, which is I just draw it here. So I don't know what that other one is. So I'm just gonna ignore that or that. Like just say that's one of them. Okay, cyclopentane. Cyclo means circles. That means connected. 5 carbon connected together. Pretty much you're drawing pentagon. Right, that's a single one, not double one. I just doesn't draw it good. Methyl, let's say a branch coming out. Okay, this one might be hard. 3-methyl 2,6-diethyl haptene. Okay, first thing first, haptene 7 carbon. 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. 2, 6. 2. Okay, that is a bad question also. You can't have 2 ethyl. You see that? That's gonna be a problem because now this is my longest chain. This is not my longest chain. Okay, so on the test, if you have the one with the 2 ethyl, these are wrong. Okay, please do not pick the one with the say 2 ethyl. Okay, but let's just say we're trying drawing it for hearsay. Let's see what kind of picture we end up with. 2, 3 is methyl. Okay, 4, 5, 6. Oh, take a look. What this scratcher is. This is not happening because the longest change is not 7. You have more than 7 in here. This is my longest change. I draw without stopping, right? I can just go continuously without stopping. This is my longest chain. And if you're counting, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. If you want to name this, it is no name, okay? And it has a carbons on 3, 4, 5, 6, 7, okay? That means it should say 3, 4, 7 trimethyl if you have that graph, okay? Not the other name, which is, by the way, I just draw it 3, 4, 5, 7 trimethyl, okay? So again, this is the misunderstanding picture, right? This will be correct naming. Now, on the test, would it be looped like this? Maybe not. It could be also straight change, like straight no name 1, 2, 3, 4, 5, 6, 7, 8, 9. You could have that, okay? Or you could have that zigzag one. It just remember, on the 3rd carbon you have 1 carbon. On the 4th carbon you have 1 carbon. On the 7th carbon you have 1 more carbon. Okay, that's what we're talking about. All right, next one. No name again. Okay, I'm just gonna change that to this one. Okay, because it's already no name, and I have 3 ethyl. So 1, 2, 3 ethyl, 2, 7 dimethyl. 2 is here. I mean, I'm gonna need to erase this. 7. Okay, 3, 4, 5, 6, 7, like that. That would be my answer. Okay, pentine, YNE. That means a triple bond. 2, 3, 4, 5. 2 pentene time between 2 and 3. Okay. 3 ethyl, 3 methyl hexane. 1, 2, 3, 4, 5, 6. 3 ethyl. 1, 2, 3. 2 carbon. 3 methyl. Right there. Okay. Methyl, 3 methyl hexane. I'm just gonna draw zigzags now. 1, 2, 3, 4, 5, 6. 3 methyl. 1, 2, 3. Right there. Okay. 1, 2, 3, 4, 5, 6. That's a hexane. All right. Name them. Okay, you should be very good with this. Let's try. 1, 2, 3, 4, 5. That's a pentene because there's a double bond right here between 2 and 3. Okay. And then it is 3 on the 3 have 2 carbon. That's ethyl. Okay. So 3 ethyl right? 2 carbon branch in a 3, 2 pentene, E, meaning double bond. Again, 2 pentene, 2, 3, right? Carbon 2, 3, because this is 1, this is 2, this is 3. Carbon 2, 3 had each 1 carbon each, so they are methyl. So 2, 3 di, because there's 2 of them, methyl. 2 of the same branch. Each branch has only 1 carbon. 2 pentene. Next one. 1, 2, 3, 4, 5, 6. 6 carbon hexane. E, because it's a double bond. Okay. Now it's between 1 and 2, but in the 2 you have a methyl. There you go. All right. 1, 2, 3, 4, 5. 5, 2 and 3. 2 pentene. E again. Okay. Since we already start calling from this way 2, this is now 4. So you're going to have 4 methyl. Okay. What you cannot do is you cannot turn around and call it from this side saying 1, 2, because you already decided from this way. Think about houses, right? Your road, if go from one way, we're gonna say 1, 2, 3, 4, 5, and then go from another way, we're still gonna do 1, 2, 3, 4, 5. We're gonna have 2 of the house with the same number on the same road. That's gonna be crazy, right? Okay, next one. 1, 2, 3. Add 3. That's an ethyl. Okay, 4, 5. That's still pentene, E. Now notice I don't need to tell the double bond location because it's between 1 and 2. Okay. Now this is a long one. Notice this is my change continuous. Now if you want to do this way, it's here, or you can also do this way. Either way is fine. 1, 2, 3, 4, 5. That's a 5. So pentene, and then you can say 1, 2. 2 pentene, and then since again this is 2, so we're gonna continue. 3, 4. It's attached to 4. Okay. So 2, 4 dimethyl. Okay, yeah, these are my M. And then pentene, right? 2 pentene. Next 2. Again, we're gonna start from this because we're gonna give double bond priority. So that means at 4, we're gonna have 2 methyl branch. So we're gonna say 4, 4 dimethyl pentene. Next one, same thing, pentene. 1, 2, 3, 4, 5. Notice this is my 2, so this is my 3, this is my 4. Okay, so that means 3, 4 dimethyl 2 pentene. Okay, these on the bottom, I just want you to tell me what kind of functional groups you have. Okay, so if you take a look at it, it's just OH. That's an alcohol. If you look at this, that's an aldehyde. If you look at it in the middle alone, that's ketone. If you look at this, carboxylic acid. Okay. All right. Same thing. We're just gonna go through them. Carboxylic acid. Okay, I'll just say acid. Alcohol. Ketone. Alcohol. Acid. Okay. That one, careful. Ester. Acid. Ketone, because it's in the middle. Alcohol. Acid. Okay. These definition, I'm not gonna do that. You should have it in your note if you have note clearly, or you can look it up. Each one: solute, solvent, solution, saturated, unsaturated, and supersaturated. Okay, I talked about that before. Now, this one you have to remember which one dissolve polar. Polar and ionic. Okay, they will dissolve in polar. Non-polar is only non-polar. What's that? These are formula that you have to remember that you're using. Molarity is molarity, mole over liter, mole divided by liter. We already have mole. 0.365 divided by milliliter, so we need to change into liter. That become 0.4 liter. Okay, 0.4. You're gonna divide these, and then that's your answer. Okay, we're gonna do the first one, like I said, 0.365 divided by 0.365 divided by 0.4. You're gonna get 0.9125. That's going to be molarity. On the test, I might have rounded and say I might say 0.913. Either way, you'll find the answer. Okay. Make sure it's with the liter and not milliliter. Otherwise, you're going to get a wrong answer. Next one. Moles. This is 0.4. Oh, wait. I actually have the same number. Oops. I forgot to change them. So you are having the same question 3 times. So you can just use that one. Next one, yeah, I forgot to change it. So you're having the same question 3 times. Just do this one. Okay, liter, milliliter, molarity. Okay, so we're gonna do molarity time liter. 0.65 times 2.4. Hello. Okay.